Hello, and welcome to SUSECON Digital 2022. I'm excited to be speaking here, and I'm going to be talking about managing external secrets in Kubernetes. All right, just a quick run through of the agenda here. We're going to be looking at the problem. What exactly is this problem? With managing secrets. We're going to be talking about a solution, which we call ESO. All right. We're going to be seeing how ESO solves this problem and how you can, work with this solution in your Kubernetes environment. And would also look at the current state of this solution. Quickly, I'll talk about myself. All right. My name is Illeriayo Adebiyi, or you can call me Illeri if that's too difficult to pronounce. So it's Illeri for short. I'm a cloud native engineer at Container Solutions. At Container Solutions, we help companies become cloud native. All right. I also enjoy teaching, and I started something called Get Going with Kubernetes, where I help people, get going with Kubernetes via book reading, via workshops, and yep, I started this early this year, 2022. I'm also co-organizer of Kubernetes Community Days Africa. So I also enjoy volunteering at for things in tech, and so I'm championing the adoption of cloud native in Africa and the development, of course. So outside of tech, outside of technology, outside of work, I'm a preacher. All right, I preach the gospel, and yeah, that's some introduction about myself. So let's move into our talk for today. So, what's this problem that we're looking at? We're talking about managing secrets. Let's take an application, a simple application. For example, the application talks to perhaps some cloud service, connects to a database, and yeah, it's a simple application. Username, password, talking to something somewhere. And but as you begin to build, or as you begin to evolve your systems, you have multiple applications running, especially in Kubernetes, and you have multiple services that they connect to, multiple databases, multiple cloud services, and all of these things need credentials or accesses, like I said earlier, username, passwords, and other credentials like that. So, but as your environment evolves and matures, you're going to have something like this, and it becomes a challenge to manage it. All right, and if your secrets aren't managed properly, then your system is prone to disaster. And so what you would want to do is manage your secrets properly. You want to be able to, you know, ensure that your security is in check, it's on point. And so when you think about this, you might be thinking of, okay, for instance, there are some people that are migrating to Kubernetes. They already have some way to manage their secrets. All right. Or even if you're already in Kubernetes, you might already be thinking, oh, Kubernetes secrets is not how I want to go about managing all of these services. Now, why is that? Because you end up with hundreds to thousands of secrets to manage. All right, in your multi-service, in your multi-cloud environment setup, you would end up with hundreds of secrets. That can be a problem. All right, and because you're just using Kubernetes, you may not have that functionality of secrets rotation, because that's one of the good practices, to embrace, to rotate your secrets regularly. And your system is evolving, you're having multiple services. It becomes harder and harder to onboard people, to onboard services, and to give accesses. So distributing secrets securely can be a pain. So what's the way forward, or how can you solve this problem? So think about it this way. There are services, we're aware of services that help with secret management. All right. For instance, if you're already in the cloud, maybe AWS, maybe Azure, maybe GCP, you're probably using their secrets manager. For instance, in Azure, you're using Key Vault, we're using AWS Secrets Manager, or GCP's solution for that as well. Or you could also even be using Key Vault, pardon me, HashiCorp Vault. All right. And of course, these services help you, with policies. They help you with secret rotation. They help you with audit trail, and these things are best at what they do. And you're coming into Kubernetes, you want to begin to manage your secrets. How about we find a way to synchronize secrets between Kubernetes and our secret manager, our battle tested secret manager? Now, that's how we came up with a solution. And we're saying you're going to be having something in Kubernetes that takes your secrets from the external providers and brings them into Kubernetes, your Kubernetes environment. So, what are the benefits of this? Now, you're keeping your secrets where it's secure, all right? Because, like I said earlier, these services, these external secrets, providers are designed for that purpose, all right, to manage your secrets for you. So it's secure there by design. And you can manage accesses, you can abstract accesses. You do not want to give accesses to anybody, just anybody on the team. So these services help you with that. And you can also use features, like I said earlier, features from these services like encryption at rest. Say you take Kubernetes and you deploy an application into your Kubernetes cluster, and you probably write you create a secret in there. You're not having your secrets encrypted. For instance, the developer writes, or maybe somebody just writes a YAML file, creating a secret and checks that into version control. There's no encryption. Your secrets are just, in base 64 format, but there is no encryption. But if you have them in an external secrets provider, right, for instance, Vault, your or Key Vault, Azure Key Vault, you're having things like encryption at rest. You're having rotation mechanisms in place for you. So you're enjoying these benefits. So we want to bring that and synchronize those secrets with Kubernetes. So another thing is that you may already have secrets, before coming to Kubernetes, and you don't want to, have duplicate um, work or duplicated work. So it just makes sense to synchronize your secrets. You can integrate with those platforms and just synchronize your secrets. Yeah, and of course, that's a very, very good benefit. You can declare secret reference in your source code, and the developer doesn't have to know exactly what that secret is. All right. So there's a whole lot of benefits in this. And so I'm going to be talking about, you know, what has been going on in the community, about these things. Um, so I work at Container Solutions, and we began to work on this project called External Secrets Operator. All right. And of course, because open source, that's one of the beauty of open source. You can innovate. There's the freedom to innovate. And the community have been thinking along this line. And so these are several solutions to solve that problem of synchronizing secrets. Now if you look at the one with two K stars just below there, that's the Kubernetes external secrets from GoDaddy, right? So there were lots of solutions. There's the one from, C Martin there, AWS SSM, all right, but it was specific for AWS. And we had some, solutions here and there. And, but these things were, you know, scattered. These things were, of course, very good. We can innovate, but the community began to have conversations and discussions about merging these, solutions together, all right, and making it, very, very effective. And so, under one of these projects, we had people began, speaking about it, and they wanted to just merge this project. And so that's how ESO was born. ESO is external secrets operator. So on the GoDaddy repository, there was an initial discussion about merging efforts, and people began to list all of the projects that they had seen that seems to solve this problem. And so from there, we created a common CRD, all right, and an organization on GitHub was created, right, to handle this solution, or to take care of this solution, and it was called external secrets, and people began to migrate onto this new solution. So external secrets operator is a cloud native way to manage your secrets. External secrets operator, we call it ESO for short. Now, how does ESO work? In Kubernetes, there's this thing called the reconciliation loop or the control loop. All right, that it's I wrote on my Twitter profile one time that the control loop is like an autopilot thing. So it watches your state, your current state, and it tries to ensure that it matches the desired state. All right. So there is this thing that you define. This is how you want the state of things to be. Whenever there is a divergence, there's something in Kubernetes called the reconciliation loop or the control loop that keeps checking, and it tries to bring your state into what you have defined, into the desired state. I'll give an example very quickly. So say you have a deployment, you create a deployment in Kubernetes, and you specify that you want to have three replicas of that deployment. At different times, Kubernetes checks to see if all three replicas are running. Several things could happen, right? There could be memory problems, there could be CPU compute problems, or just something could happen, something could go wrong that would ensure, or that would stop your, or make your state diverge from the desired state. So Kubernetes keeps checking, and whenever it sees that divergence, it tries to bring it back to the desired state. So that's the control loop, and that's the image on the left here. And so the image on the right is similar to this, but this is the operator pattern. All right, so the operator pattern works just like the controller pattern. But in this case, you are allowed to create custom resources. So the control loop watches for the resources that come with Kubernetes, the inbuilt resources that come with Kubernetes, deployments, pods, just the inbuilt resources. That's what the control loop watches. But now you want to have custom resources. You want to create your own resource and extend the functionality of Kubernetes. All right. So then you can begin to develop an operator. So an operator is it's like a software defined um, um, the word operator can refer to somebody that's operating something, but then you take all of the tasks of an operator, a literal operator, and you define that in a software. All right, so that's what the operator seems to look like. But in this case, it's watching a custom resource, and that control loop thing, happens, it goes on, and it's looking at the custom resource, what you have defined, and it ensures that it takes it to your desired state. So that's how the external secrets operator work. But let's go into more details. We won't be too technical, but just to talk more about that. So the custom resources that we have defined, or we have set for ESO, is the secret store or the cluster secret store, and the external secrets or the cluster external secrets. So the secret store is namespace scoped, while the cluster secret store is cluster wide. The same for the external secret and the cluster external secret, namespace versus cluster wide. So the secret store defines how you access your external providers. For instance, AWS. How do you access your AWS? What region are you trying to get secrets from? That's what the secret store refers to. Then the external secret defines what secret you want to fetch. All right. So secret store defines how to access the provider, key vault, HashiCorp Vault, AWS SSM. That's what secret store does, how to connect to that. Then the external secret is what do I want to fetch from that provider. All right. So we split those resources based on what they do. And so the diagram on the right just shows us, how it looks like. So you have the operator there, you have your external providers, AWS, GCP, Vault up there. Then you have the operator that is fetching data, right, from that, and it's creating that secret in your Kubernetes cluster. So the developer doesn't need to know about the secrets, doesn't need to know what the secrets are. The operator goes ahead to your provider and brings that secret into your cluster. The developer just needs to pass a reference, in the source code. Now, that's the solution that we came up with. And so, what's the current state of this solution? Because we've had a number of people adopt, as we'll see in later slides, adopt this solution. But just quickly on the current state. So, prior to 0.2, we began to work on AWS, parameter store, AWS secret manager, HashiCorp Vault. Then we included right from the early stages, templating functionalities, all right, because it was just good to have that in place. And so Azure, GCP, so the three most popular cloud providers, we put in support for that. Moving on to 3.0, 0.3.0, there were lots of updates to the documentation. In zero point 0.4, we began to look at the reconciler and reporter for Kubernetes events. 0.4.3, yeah, we things began to be stable. We began to promote things to beta, and in zero point 0.5, we have the CRD promoted to beta. And in later versions, we're going to be having a two-way sync so that you can write to the provider. All right. In this case, you can synchronize data by retrieving data from the provider onto your cluster. All right. But now in later versions, we're looking at allowing you to be able to, sync from your cluster to the provider, the external secrets provider. And so that's the status of ESO at the moment. And just some quick star updates. The ESO project is above 1,000 stars right now, and yeah, we're glad that a lot of people are beginning to talk about this. A lot of people are using this project, and a lot of people, of course, like this project. Some colleagues of mine were at um, KubeCon, Cloud Native Con, and they met with people that came to just thank them for working on this project. So it's a really, really good project. And yeah, these are our supported providers: AWS, Azure, Google, IBM, HashiCorp Vault, GitLab, and of course the Kubernetes provider. Yep. And of course, you can contribute to this project. You can reach us, via Slack. You can check the website, you can check the documentation, you can look at the GitHub code, you can look at the GitHub repository, pardon me, and you can also, go to this link over there and find tutorials on how to connect to your preferred provider. And so that's the solution that we have for managing secrets in Kubernetes. And I hope that you'd use this. And on the last note, Container Solutions is hiring. So we have several of our engineers working on this project. And so, of course, we have open positions for cloud native engineering. So do please check out, that URL. You can scan the QR code there and, apply, of course. So thank you very, very much for coming to this session. See you around.